Okay, so as you're looking at the perfects page here, you can check your answers over here. So 2 to the second, 2 to the third, check those please. Let me make that larger. Some of these I did in my head, so if you see that I did one wrong, please let me know. All right, and then fourths and fifths. What we're going to be doing is using this to simplify underneath the radical sign. And I'll show you how it relates to what we did in the past. But what we have to be able to do is take any kind of a root, like you did it in the calculator, it always came out to a whole number. But what we have to be able to do is deal with it when it's not a whole number. Anybody have questions on this page? Okay, turn the page over, please. And for today, we'll have, or for the first couple problems, we'll have to flip back and forth. But when we go into the other kind, you can just use the back side of that page. So we're going to try to simplify these. First thing is to try the root. So on your calculator right now, try the third root of 128. Sometimes it'll be a whole number, sometimes it won't. If it's a whole number, then the problem's done. What do you get? Okay, good. So not a whole number. All right, so up top, if it's not a whole number, then go on to step 2. And when I say whole number, I should just say integer, because negatives are okay if you have an odd root. Negatives aren't okay if you have an even root. Okay, step number 2 is to find a quote-unquote perfect. That could be a perfect square, a perfect cube, a perfect fourth, a perfect fifth, a perfect sixth, or whatever. Find one of the perfects that is a factor of the number in the problem. Once we know what that is, we're going to split the root into those 2 parts, and then we're going to simplify each part. So write this. We're going to do the third root of and leave the bottom blank. We're going to split that 128 into 2 factors, but I'm not looking for perfect squares this time. What is the number on the little root right here? 3. So you're going to be looking at this. You're going to be looking at all your perfect thirds like you just did on the other page. The perfect thirds are 8, 2 to the third, 27, 3 to the third, 4 to the third is 64. We have to look for these numbers. Now, there's a lot of things you don't have memorized, but here's how you start. It's 128, right? So you are not going to try to divide by 125 because you know 128 is not going to divide by 125. So take your calculator and try dividing 128 by either any of these numbers that are smaller, by 64 or by 27 or by 8 until you get one that comes out evenly. And if we can, we like to find the largest one so we don't have to do more steps. 64 works? Awesome. Okay, so it's the third root of 64 times 2. That's what I mean when I say the next step, which says split the root. You split it up. But it has to be something that can come out to a whole number. The third root of 64 can come out to a whole number. So when we split it up, we're going to say it's the third root of 64 times, watch this, it's still the third root. The third root of 2. You're splitting it up. Now this is the first time I think that you've seen anything like this. So you just have to get used to the fact that we're going to be writing things with a little number in the root place. And so now what's the third root of 64? 4. That's right. That turns into a whole number 4. But there is no even number or whole number for the third root of 2. So we write it as our radical. Okay, you're not ready to do these on your own yet. I have some to do with you, but are there any questions on any of the steps that I did? All right, so let's try number 2. Number 2, we're going to be looking at the fourths now. Well, first of all, if you tried the fourth root of 32, it will be a decimal. But always try that first, because if it comes out to be a whole number, why go through all the rest of the work? So we are looking for a fourth root that would be a factor that could go into 32. 16, good. 16, you kind of already know that, but if the numbers are really big and you don't have it memorized, all you do is find that number and start with the one that 81 doesn't go into 32, so you'd have to go with the next ones after it. All right, so we're gonna split it up into 16 and 2. How do you know which perfects to look at? What part of this tells you which chart to look at? The root, the 4. Good. Okay, so it's the fourth root of 16 times the fourth root of 2. 2 can't be broken up anymore. There are no fourths that go into the 2. So what's the fourth root of 16? 2. So our answer is whole number 2 times the fourth root of 2. Number 3. Look at that fourth root chart again. And I don't want everyone to just call it out. I want you to give it a minute and let everybody find a fourth root that could go into 405. Now don't try them all. Be logical and try one that is smaller. You're not going to try 625. That's too big. Try 256. Try dividing by 81. Try dividing by 16 until you find one that works. 81. 81 works? Yeah. Okay, good. So in a second, tell me what that is. It's 81 times 5. Good. 81 times 5. So whenever you're dividing, stop and look at what that whole number result was, and then that's going to go inside of your root there. Questions on where we got the 81 and the 5 from? You know, this part is easy because you already have your chart there. Tells you what the fourth root of 81 is, and the fourth root of 5th can't be simplified. How come I'm not dealing with the fourth root of 5th, a fourth root of 5? How come I don't try to break this down? None of the perfect fourths can go into it. Yep, that's already simplified. So, fourth root of 81, is that 3? 3 to the 4th is 81? So if you look at this, if you look at your chart, 81 is 3 to the 4th. So the fourth root would be the 3. Or if you do your calculators, you can do the root, the fourth root of 81, and you'll see it comes out to be 3 as well. When you have the chart, you can use it. If the numbers go too big, you'll have to use your calculator for it. All right, number 4. This one's different because we didn't make a 7th root. We didn't make a 7th root chart for us. So we're going to look at this one, and you're going to have to use your calculators for this one. Okay? So take your calculators, and the first thing we have to do is find a 7th root that goes into 768. So we know, let's see. I wrote myself a hint for us over here. It's even, so let's start with the 2's. Okay, so take your 2's. Do 2 to the 7th. See what you got. Okay, I'm going to write this off to the side here. 2 to the 7th is 128. If that goes into 768, you could use it. What would you do if 2 to the 7th didn't work? What would you try? We want a 7th root, though. What would we try? 3 to the 7th. Yep. And if that didn't work, what would we try? 4 to the 7th. We'd try all the 7ths. So let's see. Does 2 to the 7th work? Can you divide 768 divided by 128? It comes in evenly, so it's 128 times 6. Okay, so if you don't know the root, you just have to try all your low numbers, 2, 3, 4, 5. Try it to that power until one of them goes into the number. Most of your work is going to be on those charts, but I just thought I'd throw an extra one in there. So what could I say is the 7th root of 128? 2, good. And this one, the 7th root of 6, doesn't simplify, it stays as it is. So for number 5, look at the root there, look at what number we were dealing with, and tell me which chart should I look at? The squares, the cubes, the fourths, or the fifths? The fifths, good. For number 5, it has a 5th root. So you have that on your paper, but I'm going to hold this one up as well. Don't try any numbers that are way too big for 160 anyway. Try the numbers that are smaller than 160. Which one could work? 32 goes into 160. So I'm going to ask you in a second. It's the 5th root of 32 times what? Times 5? There you go. Any questions on how that works? I mean, it had to be 32 or nothing, right? Because all the numbers were bigger than 160. Okay, so it is the 5th root of 32 times the 5th root of 5. What answer is that going to come out to be? 2, 5th root of 5. Does anybody have a question on where this number in front is coming out of? You guys know how to read the chart, or you can take your calculator and do the 5th root of 32. The whole point is to make it come out as a whole number. Try number 6 on your own. Which chart are you going to look at? The thirds. Good. The perfect thirds. Find one of those factors that can go into 375. Which means it can be used for any number that you define. So I'll show you that when the video is off. Okay. All right, so what do we get? 125 times what? 3. So you should have 3rd root of 125 times the 3rd root of 3, and it comes out to 5 3rd root of 3. Questions on that? Okay, so another thing you need to know is how to handle it when there's a variable in it, which for math 2, we're not going to give you the most difficult kinds. So for number 7, all you do is this. We're going to look at the fourths, and we're going to break that up. Look at your fourths chart. Which number can go into 486? What are our possibilities? It's either going to be 256, 81, or 16. Is it 81? 81. Times 6? Yeah, 81. And then times n. Bless you. Now, if this exponent is ever higher than the outside number, you'll have to deal with that, but that'll be math 3. We're going to have some that this exponent on the n is never going to get too complicated for you. So it's the 4th root of 81 times, we don't know the 4th root of 6, it's not a whole number, and we don't have a 4th root of n, so we put the 6 and the n together. Those are stuck together, they don't get simplified. So my final answer would be, do you know the 4th root of 81? 3 times 4 radical 6n. All right, and the last one, number 8. It's going to be the 3rd root of, we're going to break the 32 down into what 3rd root would work? What perfect 3? Perfect 3rd? 8 times 4 would work, right? And then we have v squared. All right, which ones go in front? Just the 8, right? You can't take the 3rd root of 4. You can't take the 3rd root of v to the 2nd. So this would be 3rd root of 4v to the 2nd. The 3rd root of 8 becomes a 2, so it's 2 times the 3rd root of 4v to the 2nd. Questions on that? Okay, turn that paper over so you have your perfects chart in front of you, and open up your notes, please, to 10-4. 4. And I want to show you, the rest of it is easy. This was the hard part. The rest of it is just rewriting things that you already know from the beginning of the chapter. And I want to just make sure that you can do this more difficult part as well. All right, so you need your calculators because some of these are going to come out to be whole numbers and some of them won't be. Rational exponents. We've studied this a lot. The number on the bottom goes out in the front. The number on top stays as our exponent. So the first thing you do is check to see if it comes out to be a whole number. Number 1, in your calculator, try to find the third root of negative 216. Or look on your chart there, since you've got in front of you, what's the third root of 216? Yeah. 6, good. I thought I gave it the answer. Is it 6 in this case? Negative 6, good. So you're allowed to have a negative under here if it's a third root. You're only not allowed to have it if it's a square root or a fourth root because all the negatives would have canceled out. All right, try number 2. Is there a sixth root of 262,144? 8. Oh, you figured out how to use it. Good. Questions on that one? Do we all agree? All right, try the fourth root of 80. What does it come out to be? Not a whole number, right? It's a decimal? Okay, so look at this one. The fourth root of what and what? What fourth power, what perfect fourth could go into 80? 16 does. That's right. 16 times 5. Now you know how to do that. We're going to do the fourth root of 16 times the fourth root of 5, and then it's going to give us 2 times 4 radical 5. Fourth radical 5. All right, number 4. I don't think the third root goes into 88, does it? If you look on your chart, you can tell that there's no 88 in the third root, in the perfect thirds. So we're going to have to split this one up. Are we allowed to have a negative in the third root? Yeah, because 3 negatives can make a negative answer, but 2 negatives can't make a negative answer. All right, so I know it's going to be negative. It's going to be the third root of what and what. Look at that closely and see which third root can go into 88. Look at your perfect thirds, perfect cubes. 8 would work, right? 8 times 11. I already put my negative sign out in the front. So that's the third root of 8 times the third root of 11. What's the third root of 8? 2 times the third root of 11. That's the way you write your answer. And number 5, look at your fourth chart. Is there a perfect fourth for 128? No, because none of them equal 128. So let's split that one up. And what are we going to break it into? Look at your perfect fourths. What times what? 16 times? And that's the only possible one, right? Because 81 times 2 would already be 160 something. That would be too big. All right, so that would be the fourth root of 16 times a... And then it would be 2 to the fourth is 16, right? So it'd be 2 times fourth root of 8. Okay, that's the hard part. This next part is, you've done it before, I'll say that. Okay, the directions say to write in radical form. So do number 6 right now on your own. See what you remember. Write it like this and put the 6, the X, and the 5 all in the right places. Okay, so where did the X go? Where did the 5 go? Either way, as long as it's an exponent. And where did the 6 go? As the root. Okay, the 5 can be under the radical or outside the radical, just has to be as an exponent. All right, number 7. What is, here the 5/6 was touching the X. What is the 1/3 touching? Parentheses. So the whole entire parentheses goes down underneath the radical. The entire parentheses counts now. What's the root? And what's the exponent? So we don't even really need to write it. But you can. The 3rd root of 2p. All right, for the number 8, what is the exponent touching? Only a v. So underneath the root is the v. So the 4th root goes out here and the 3rd exponent goes right there. Number 9. What is the exponent touching? The parentheses. So the entire parentheses goes under the root. So that's 8m. What is the exponent on 8m? 2. And then what we're changing to a radical, so the 3 goes on the outside. Questions on how that works? Try number 10 on your own. What is the exponent touching? So when you do it, put the whole entire parentheses under the root. All right, so you should have had the 3rd root. No, I'm sorry, the 2nd root, which we don't have to write. Square root is the same as the 2nd root of 7x to the 3rd. Okay, now this next one, I want you to copy it down. Number 11. Write it. 32x to the 1/5. Copy it down, I just added it in there. What is the exponent touching? The x. Does it have anything to do with the 32? No, and that's the difference between number 10 and number 11. So underneath the radical is the x only. Out in front of the radical is going to be the 32. So it's the 5th root of x to the 1st, but the 32 is still a coefficient. It's still out in front. So as you're doing problems, make sure you consider what that exponent is actually touching. If it's parentheses, great. If it's not, then only do what it's touching. All right, so turn the page, and instead of just doing notes on this, let's just have you guys do it really quickly. You guys already have seen this, so it's not anything brand new to you. But let me just do the first 2. Make sure you know what they're looking for. They want you to write it as an exponent now, so you take your 4 and your 3 and you put them in the right place. What goes on the bottom? The 3, the root. The number out here is the denominator. So the 3 goes here, and what goes on top is the 4. This is the numerator. The denominator and the numerator. Okay, so if you look at number 2, there's an imaginary 2 right here for a square root, and there's an imaginary 1 right there. So write that 1 as an exponent. Now, what's underneath the root? The whole thing. So you would want to group that in parentheses as you go. Okay, the 5 and the r are both under the root. So it's 5 and r to the what? Okay. I'll do one more with you. Number 3, because it's different. What's under the root? The v. The 2 has nothing to do with the root. So it's v to the whatever what? And the 2 is out in front, completely separate. All right, finish that page. Just write them all up as exponential form. Number 4 through 6, 4 through 7, check those. Any questions on that? Number 8 through 10. I hope in number 9 you realize that the 7 and the r both were under the root, so they both get included inside the parentheses.